You're welcome back. Tell me, what time is it now? Let's check our time. Wow. It's your time to pass, right? Okay, so let's look at slurry pumping. Slurry. Right. So what is slurry? Now, a slurry is just a semi-liquid or a watery mixture, a watery mixture of insoluble matter. All right. It's typically maybe fine particles of manure. Okay, it can be cement. You can mix water with cement, or even a mud, or lime, or plaster of Paris, POP, or coal. Okay, you can mix coal with water. Why do we have to mix this? Let's assume that you want to lift 10 tons of coal from this point to a certain height of, let's say, 100 kilometers, for instance, or 100 meters. Now, it will be very tough to lift such amount of coal. So sometimes you can mix that coal with water and then pump it through a pipe. All right. So when we talk about slurry, we are saying a mixture of any of these with water. So, and if you mix this with water, the slurry that you are going to have will behave in some way like a thick fluid. Okay, like a thick fluid. Now, flowing under gravity as you are lifting it up, as you are pumping it, and they are also capable of being pumped if not too thick. And once you are dealing with slurry for GCC equations or any kind of equation, remember that I said a slurry is going to be a mixture of water and any of these. So we can say it's a mixture of water, let's say sand, for instance. Okay, slurry. So when you are solving slurry equations, it's always important to note this, that the mass flow rate or the mass of the slurry is the same thing as the mass of the water. The mass of the water plus mass of sand. Now this is what you need to know. Okay? This is what we need to know, so that if you want to, we know that density is mass over volume, right? So it means that mass is density times volume. So we can even convert this to, density times volume instead of using mass. So, but just note this, you will use the mass of the slurry is the same thing as the mass of the water plus the mass of the sand. Okay, so even if you are looking at the mass flow rate, remember if I put here, that's the mass flow rate of this slurry. It's mass flow rate of the sand and mass flow rate, mass flow rate of the water plus that of sand. So mass is density times volume, so it can be density of slurry times volume of slurry. Okay. Now you said this is the same thing as for water, is density of water by volume of water plus density of sand by volume of sand. Okay. Okay, somebody asked a question, is slurry pumping part of factories? Yes, slurry is part of factories. We are going to solve if the problem, one of the factory questions. Okay, slurry is part of factory. Look at this question we are going to solve at the end of this course. At the end of this, you should be able to solve this problem. This is factories, November 2004, question 5.1, which was also repeated in June 2010, question 8.1, and also repeated in November 2010, question 8.1. All right, it's factories. So you can expect questions like this, whether it's factory or mines. All right, so now, do you know one thing about slurry? When you are solving problems, two things you should know. The first one is that you say mass of slurry is mass of water plus mass of sand, because you are mixing the sand with water. So you get mass of water, mass of sand put together. Number two is, when you want to consider the, if you want to know the amount of water that you are going to use to move a certain sand from point A to point B, the very first thing is you must work out the whole of this with respect to 1 meter cubed of slurry. So you work out 1 meter cubed of slurry. In other words, you will say, okay, if we have, for 1 meter cube of slurry, what will be the volume of water and the volume of sand? Because if I have this as a volume of slurry, V of slurry, as 1 meter cube, now you pour water in and you have your sand. All right, now it means that for 1 meter cube of slurry, that is the volume of slurry, being 1 meter cube, if I want to get the volume of maybe water, volume of water will be 1 minus volume of sand. 1 minus volume of sand, because 1 meter cube now, if I can remove the volume of sand from that 1 meter cube, I will get volume of water. Or you say the volume of sand, okay, is 1 meter cube of slurry minus the volume of water. All right, now these are the things that you should know. This is what you should know, this and that. Okay? All right. Okay, remember last time also, we said if you want to calculate maybe the power of a pump. So if a pump is going to pump a slurry from ground level to a certain height, right? Now, that if I pump something from here to here, and I know the head, right? You can get the power, rho G H HQ will be the power. So if I know how much Q, how much flow rate that is being pumped, I can multiply with the head, multiply with G, multiply with that to get power. Okay, remember that? That's what we did last time. So if I have that pump here, and if efficiency is given to you, you can divide by efficiency to get the power into the pump. And also, if you want to get, you can also use maybe work done over efficiency as power. If I know the total mass, the mass of slurry that is being pumped, then I can multiply that mass with GH, all right, like that. And then with that, you can calculate. That will be the power. So either you use rho GHQ or MGH. Remember, when you lift something from here to this point, it's going to have a potential energy, okay, or work done of mg. mgh, mass times gravity times height. So we can still use this as power. So if I have power, it can be mgh, okay, or it can be rho GHQ. So if you are given efficiency, you divide by efficiency to get your power into the pump. All right, that's by the way. Now let's look at just one question before we can solve our previous exam question. Look at this kind of question. All right, so from that question, it says that you are required to calculate the power needed by the pump to deliver 40 kilograms of dry sand per second. If the total head is 10 and specific gravity of sand and slurry are 2.6 and 1.3 respectively, and the pump efficiency is 65%. Now, you need to pump. You want to pump 40 kilograms of 40 kilograms of sand. What comes out here is 40 kilograms of sand per second. Remember, what is this? This is a mass of sand. What? 40 kilograms. That's per second. You want to pump 40 kilograms of sand per second from here to that point. Remember, this is pure sand. That means for you to get this, you need to have a slurry that contains sand and water. And then when you get to this point, you can now separate the sand from the water. And then you now dry your sand to see how much that we are going to get. And from here, we are getting about 40 kilograms of sand in 1 second. All right, so that means I'm going to have this pump is going to push mass of slurry, which I don't know. But when it comes here, you are going to have mass of water and this mass of sand. Okay, you are going to separate that. So we want to know what will be the amount of power that you required to push, to supply, to pump this 40 kilograms of sand per second. So for me to know that amount of power, I need to know what is the mass of the slurry. And for me to know mass of slurry, I know mass of slurry is mass of water plus mass of sand. So I must know the mass of water, so I can add it with this mass of sand. Okay, so that from here I'll get to the mass of slurry. So that if I want to calculate the power input into the motor, into this motor, I can now say P is now mass of slurry that we are going to calculate. Okay, mgh divided by efficiency. Okay, this is for our slurry. Or if I know the rate, the flow rate, I can just put P is rho GHQ over efficiency. Okay, so let's start. Let's see how we can get this. As I said, when you are given a slurry equation, just note this first, that mass of slurry is mass of water plus mass of sand. All right. And if I'm talking about the rate, the flow rate, okay, the mass flow rate, we put that this is with time. And then the mass of slurry, we said is the same thing, mass, density is mass over volume. So that means mass is density times volume. So I'm going to write this to be a density of slurry by volume of slurry equals density of water by volume of water plus density of sand by volume of sand. Okay, let's check. Let's check from the equation what are given. We are given 40 kilogram dry sand. Okay, and they were also given a head of 10 meters, and were given the specific gravity of sand 2.6, Sg of sand 2.6, and Sg of slurry 1.3. 1.3. What does that mean? Now remember, we're talking about specific gravity in this case, which is your relative density. So if I have this specific gravity, which is relative density with respect to water, the density of water is 1,000. So it means that density of sand is 2.6 times 1,000. Okay, that's 2,600. Why this is 1,300. Okay, so now that's about that. Now let's come back here. So I said, now when you have this, before you start solving, the very first thing is you need to consider how much that it will take to pump a solid sand, a certain amount of sand for 1 meter cube of slurry. So you just say for 1 meter cube of slurry, that's what we're saying, if V slurry is 1 meter cube. Okay? Now, what will be the volume? V of the V of water, depending on what you want, will be 1 meter cube volume of slurry minus V of sand. Like that. So that from here, we can substitute these things here. So density of slurry, all right, by volume of slurry, and we are taking volume of slurry for 1, which is 1, equal to density of water by volume of water, and volume of water is 1 minus volume of sand. Okay, now plus density of sand by volume of sand. We can see that from here, we can make the volume of sand subject of the equation. So we can easily calculate the volume of sand. Let's put what we have. Slurry density is 1,300. Density of water is 1,000. 1 minus V sand plus density of sand is 2,600 into V sand. All right, so when you do that, you can easily calculate, just check what we have here. You can divide all through by 1,000, so that you have 1.3 equals 1 minus V sand. 1 minus V sand plus 2.6 V sand. So this is 2.6 minus that, minus 1 of V sand, will give you 1.6. So 1 plus 1.6 V sand is 1.3. 1.6 V sand, 1.6 V sand is 1.3 minus 1, which is 0.3. V sand is 0.3 over 1.6. 0.3 divided 1.6. You get about 0.1875. So we get 0.1875. What does that mean? This is the volume of sand for 1 meter cube of slurry. This is a meter cube. Volume of this per meter cube slurry. Okay, did you get that? Now, which means that the mass of sand, we can easily calculate the mass of sand in 1 meter cube of slurry. See this? What this thing means is that 0.1875 meter cube of sand is for 1 meter cube slurry. That's what that means. Okay, so now this is volume. We can easily calculate the mass. What is mass? How do we calculate mass? We said density is mass over volume. Mass is density times volume. So we can say that mass is density times volume, right? So what will be that? 1,000. This is sand, right? And the density of sand we get at 2,600. So I'm going to have 2,600 times this volume. Remember, this is a volume, 0.1875. Let's just see. I'm going to explain again what I mean by that. 0.1875 times 2600. That's 4875. 487.5. What is that? This is the mass. Remember that what we got here is the volume of sand. What will be the mass of that sand? So this is mass. Let me just put it here. Mass of sand. But that mass of sand is just for 1 meter cube. So mass of sand for 1 meter cube is density times volume, which is 2600 times this volume, which will give you 487.5. But this kilogram is only for a meter cube, 1 meter cube slurry. Okay, but so if I can get 1 meter cube for 1 meter cube slurry, you will be able to get about 487.5 kilogram of sand. But if you check the equation, you can see that what is being pumped is we want to deliver 40 kilogram of dry sand. But for 1 meter cube, we can get this of dry sand. Okay, that is to say, 1 meter cube, 487.5 kilogram of dry sand is only for 1 meter cube of slurry. But in our case, what we are pumping about 40 kilogram of dry sand. So how much meter cube will that be? So what will be the volume of the slurry? Because the volume of the slurry for 1 meter cube will be able to deliver 487.5 kilogram. Now, what about if I need to deliver this? Because from the equation, we are told that we need to deliver 40 kilogram. Okay, so what will be the mass? What will be the mass of the slurry? So it will now be this times this over that, which is 40 times 1 divided by 487.5. Okay, so we have 487.5 as 40 divided by that, 0.08205, right? As 0.08205. 0.08205. This will be the mass of slurry. So this will be how much. Remember that what we have here is now a meter cube. Okay, mass of slurry. So this is how much that we need to mix here, about 0.08205 meter cube of slurry that we need to pump to this point for us to get 40 kilograms of sand. So once we have mass of slurry, that's all you can now solve. Because we said efficiency is either you say mass of slurry by GH over this, or rho GHQ over that. So since I have gotten mass of slurry here, then I can easily calculate the power. Okay, so pump power, P in, pump power, input. All right, remember, it's going to be mgh, better divided by efficiency. Remember this power here, this energy here, energy that we got there, mgh. Now, if I just put like this, the rate with time, now we now get our power. All right, this is energy, mgh. Now, with a dot, which is with time, we get power. That's all. So we can just use that. M is already given to us as 0.08205 times 9.81 times the height that you are pushing that, you are pumping that. Now divide by efficiency of the pump that is given to us is 0.65. So you divide by 0.65. Okay. This is if you want to use this method, if you want to use that to solve. So if you divide that, 0.028205 times 9.81 times 10 divide 0.65. So you get, let's see that, 0.0, did I miss anything on, oh, rho G, I mean GH, okay, yeah, it's fine. That means the formula for, okay, I think that's all. So we have 0.08205 times 9.81 times 10 divided by 0.65. So check 12 point something. I think there must be something I'm missing somewhere. I've gotten about 0.082 as the mass, or I mean the volume of sorry. What is this? Did I get okay, so sorry, this is a mass, this is a mass flow rate. So have this 0.08205 as the volume of the slurry that is delivered. So I'm sure there must be a mistake here. 487.5 kilograms of dry sand is for 1 meter cube of slurry. So what will 40 kilograms of dry sand be? What will be the volume there? So I don't know why I put this. You see? So please just make the correction. This is not mass, this is volume. Let's write it here. So that means volume of slurry. The volume of slurry that we will need to be able to pump to get about 40 kilograms of mass, okay, will be this times 1 over that. This times this over that, which gives you this, okay? This is volume of slurry. Okay, sorry about that. Okay, so that if I want to calculate, remember in the question you might be asked to calculate just the volume of slurry, then you will stop here. If I want to calculate the mass of slurry, say mass from here is density times volume. Density times volume, okay? So what's the density of slurry? Density of slurry 1,300 times what's the volume of slurry? 0.08205. Okay, this is what I was looking for. All right, so we can easily use this and say efficiency. Power in, P in is P out, or energy, mg h divided by efficiency. Just put this is the rate of flow, mass flow rate. So which is this is 1300 times 0.08205 times 10 divided by 0.65. Okay, I think that's yeah, this is what I want. Okay. Now I have 1300 times 0.08205 times 10 divide 0.65. Okay, let's see. I have I forgot 9.8 times 9.8 times 9.81. Remember, is m. M is the whole of that. This times this. G 9.81. Then 10 over that. Okay. So I have 1300 times 0.08205 times 10 times 9.81, then divide 0.65. Okay, so you get 16.1 kilowatt, or 16 kilowatt. All right. So that is the. If you don't want to use this, you can use power is rho G HQ over efficiency. So we must calculate this. What is this? Well, this is a volume flow rate. So you can easily calculate volume flow rate. All right. Well, do we have any volume flow rate from here? If you want to calculate that, just check very well. What is this? This is this per seconds. That means this is like this. And volume flow rate is Q. That's all. So if you have Q as that, you can multiply by H, multiply by G, multiply by this over that. Then you get the same thing. All right. So what I'm saying is, I'm going to have, what is this? For the slurry, it's 1,300 times, what is that? 9.81 times, what is the head is 10, what is Q, which is the volume flow rate, 0.08205. That's all. Divide by 0.65. Any one you want to use. So you see we get the same thing. So we'll have 1300 times 9.81 times 10 times 0.08205 equals that, divided by 0.65. You get the same thing, 16.09, that is 16.1. All right, you get the same 16.1 kilowatt. All right, did you get that? What time is it? Wow, it's your time to pass. Okay, so let's now look at this question. I think this is one of the past questions. Let's look at so let's look at this question. This is November 2004, which can be repeated now, who knows. And it's a repeat also. It was repeated in 2010, and also, yeah, November 2010 and June 2010. So you can try it. All right, let me clean the board. Okay, so now let's look at that question. Now it says the sand. Let's check the sand. Density of sand is 2,600. Okay, the sand of density 2,600 when dry is pumped as a slurry with a density of 1,400. So density of slurry is 1,400. Okay, now it was pumped through a pipe with a friction coefficient 0.007, friction coefficient 0.007 from a sandy area. So we pumped the slurry, okay, from a sandy area. We mix everything with water and then pump it. And then the length of the pipe length is 1 kilometer. Pipe length. One kilometer, and discharges 250 meters above the pump. 250 meters above the pump. Okay, 250 meters. Above the pump. Okay, and then assuming the flow of 2.5 meter per second to prevent settling velocity. 2.5 meter per second. Okay. For transfer rate of 50 tons per hour of dry sand, 50 tons per hour of dry sand. That is the mass of dry sand. So that is mass of sand is 50 tons per hour. Okay. The question is now to determine how much water is used per hour. The first one is to how much water is used per hour. Remember, we are going to mix water with the slurry. So how much of the water that you'll be putting in the slurry, okay, to mix per hour for you to be able to deliver a sand up there up to 50 tons per hour. Okay. Number two is to calculate the size, the suitable pipe size. Calculate pipe size. And number three is how much electrical power is needed for the pumping operation. Power. Okay, so now, so you are given this kind of question, and you've listed, these are parameters, all right? So the sand, the slurry, the length of the pipe. Length of pipe is about one kilometer, and then also the static head. Remember, I don't know, they didn't tell us how this is. It might be that the pump is like that. I mean, the pipe is like that, and then it's a static head. Static head, which is a head between that and that, right? And then you pump, you put your pump, you push water, then up to that. And that static head is 250 meters. That's the head. For you to lift water from here to here, at least you have certain amount of power. You need an amount of power, mgh energy, to move from here to that point. As you are pumping this, there's going to be some frictional forces also. So you are going to have total head to be static head, head total to be static head, and frictional head. Okay, that's why you are given something like that, right? If they say we must calculate power, you should know, we say power is rho g hq, all right? So our H is going to be both static and friction head. Now, let's start. How much of water is used per hour? Okay, and I said, just hold on for me. All right, so now, as I said, when you are solving slurry equation, just make sure that you know that mass of the slurry is the same thing as the mass of the water plus that of sand. Mass of water plus mass of sand. That's where you start. So that with mass, we said is mass is density times volume. So to be density, the density of slurry with volume of slurry. Remember what we just want, because for me to get power, I just need to see how I can calculate Q. Remember, Q is your volumetric flow rate. So if I can get the volume of the slurry, then that will be great. Okay. So now, density of slurry by density of slurry by volume of slurry is the same thing as density of water by volume of water plus density of sand by volume of sand. Now, you start first of all by considering just 1 meter cube of slurry. We want to see how much that we are going to pump, how much dry sand we can get. So for 1 meter cube of slurry, what does that mean? Meter cube is a volume of slurry to be 1, right? So if I take volume of slurry to be 1, then it means that we can say the volume of water will be volume of slurry minus volume of sand. Okay, so volume of water will be 1 minus volume of sand. So we just take this and add these two things and put there. So we have density of slurry by volume of slurry, which we said is 1 in this case, equals to density of water by volume of water, and volume of water is 1 minus volume of sand, 1 minus volume of sand, plus density of solid of sand by volume of sand. So once we get this, you can substitute. All right, what is the volume, what is the density of slurry? Is given to us as 1,400, 1,400 equals to that of water is 1,000, 1 minus V of sand, plus density of sand is 2,600 Vs. You can divide all through by 1,000 so that you have 1.4 is, this is 1 now, 1 minus Vs plus 2.6 Vs. Okay, so this will be 1.4 is 1 plus 1.6 Vs. So that Vs will be 1.4 minus 1 over 1.6. So we'll get that 1.4 minus 1 divided 1.6, which is 0.25. Now, this 0.25 is the volume of sand, but per meter cube of slurry. So that if you want to get even volume of water, remember we said, what is it? Volume of water is 1 minus that, okay? I mean 1 minus 0. This, which is 0.75. This is meter cube per meter cube slurry. This is meter cube per meter cube slurry. Okay? That's the volume of water and volume of sand. So once you have this, then you can easily calculate. So we have seen that the mass of sand, we can easily calculate the mass of sand for 1 meter cube slurry. Because if I have their volumes, this is the volume of sand, what will be the mass? Mass is density times volume. So it means if the volume of sand, let's put here, so volume of sand, okay, in a meter cube per meter cube slurry, we got that to be 0.25. That means the mass, our mass of sand will be density times volume of sand. Density of sand is 2,600. So we have 2,600 times volume of sand 0.25. This will give you the mass of sand. Okay, let's multiply that. You have 2,600 times 0.25. You get about 650 kilogram. That's the mass of sand. Okay, or you can put it as 0.65 tons. But this is mass of sand just for 1 meter cube slurry. This is for 1 meter cube slurry. Okay. So we can now use this to get the volume of slurry, because here, if you check the equation, we need to pump how many? Let's see the equation here. We want to pump 50 tons per hour. 50 tons. So what we are going to do is, you say, okay, if 0.65, this is divided by 1,000, just to make it in tons. 0.65 of sand, kilogram sand, of sand. That's how much you can deliver when you have 1 meter cube slurry. If you have 1 meter cube slurry, you should be able to deliver 0.65 tons. But from our equation, we want to deliver about 50 tons. So what will be 50 tons? You just use primary school. What will it be? Just this times this over that. Okay? So which will be 50 times 1 over 0.65. This is how much this will now be, because it's from 1 meter cube of slurry. What I've gotten now here will be the actual volume of the slurry that we will be able to get about 50 tons, okay, of dry sand. Let's just get that 50 times 1 divide 0.65. That is 79.92 meter cube slurry. 79.92. So 79.92 meter cube. So volume of slurry will be that. Okay? So that's our volume of slurry. Meter cube. If you are dealing with per hour or whatever, just make sure you have that. But it is 79.92 meter cube. All right? So that is how much that you will need to be able to, that you are going to have your mixture of sand and water to be able to deliver 50 tons of sand. So you can also come here also, check the same thing. This is for water. What is water? We said the volume of water, because what they want here is how much water. This is in case if you are asked to calculate the volume of the slurry. Now the question is how much water is used per hour. Remember that when we got this volume of water is 0.75 meter cube per meter cube slurry. Okay? That's just per meter cube. So 0.75 meter cube this is for 1 meter cube slurry. Okay? So how much water will be needed for what? For this amount of slurry, because this is the volume of slurry that we have calculated. So how much will be needed for 79.92 meter cube slurry? How much? So you just do again, go back to grade 12. So it will be this times this over that. So this will be, so that means how much of water per hour? So it will be 0.75 times 79.92. Okay, 79.92 times 0.75. You get about 57.692 of water. 57.692 meter cube of water. Okay, that is the volume. So sometimes I might ask you what will be the volume of water? But here they said how much of water. So they said how much of water, we're not dealing with volume, we're talking about the mass. But if I ask volume, now this is the volume of water needed. So if we now want to get mass of water, it will now be, mass is density times volume, which will now be 1,000 times 57.69. Okay? So remember that this is This which will give you 57690 kilogram of water. That's how much of water, which can give you 57.69 ton of water. Okay, that is that question. That's the answer to that question. 57.69 tons, all right, per hour. Now that's our mass. Remember, that is a mass flow rate because we're dealing with per hour in this case. So that's a mass. That is this one. If they say you must calculate the volume, we are using that one. If you say calculate the mass, we're using this one. All right, did you get that? What time is it? You say it's time to pass, right? Now the next question is to calculate pipe size. How do we get the pipe size? Remember, for you to know the size of the pipe, you need to know our continuity equation, where we said Q is VA. All right. So I'm just going to clean here. I think I'll just clean here. Well, we say that Q is V. I hope you know what Q is. This Q is volumetric flow rate. The flow rate, volume with time. Where is it? Where did we get the volume of the slurry? This is volume of the slurry. Okay. So now, what we do is, for us to know this pipe size, this is V pi d squared over 4. I just need to know the diameter, that's all. So if I know this, all right, then I can easily calculate the diameter. And for us to do that, I need to now get the total mass of our slurry. If I get total mass of slurry, then I can divide by the density to get the flow rate. Okay. Let's see. Yeah, I think that's all. Let's just get this density. Density is the same thing as density is mass over volume. I mean, this is mass over volume. So volume is mass over density. That's mass over density. Okay, all right. I think so. This is volume flow rate, mass flow rate over density flow rate. I just want to see what is the mass of the slurry. We didn't calculate mass of slurry anywhere. We did not. All right. But we can even use this, the volume of the slurry. They will give you the same thing. You can even use this as slurry volume. But if I want, let me just see. We put an equation. We said mass of slurry is mass of water plus mass of solid. All right. So what did we calculate as mass of water? We got mass of water as mass of water as 57 mass of, yeah. We got mass of water. This is mass of water plus mass of solid. I'm just dividing by that. And we got mass of water as 57.69, and mass of solid is given, which is what needs to be pumped. See what has to be pumped. 50 tons. So 50. So 57.69 plus 50, you get about 107.69, 107.7. 107.7. That's our mass of the mass of the slurry. So I divide by density. The density of slurry is given as 1400. 1400. That's 1400. Okay, you can easily calculate that. Why do I need this? I just want to get this so that I will now make the diameter the subject formula. And then that will be, then I'll get the size of the pipe. All right. So, let's divide that. That is 107.this divided by 1400. 0.0769. So now 0.0769. Is it okay? Oh yeah. Remember that this is in tons, so I can multiply by 1. This is 50 tons. This is tons. All right. So you divide that, you get 0.0769. So 1, 2, 3. 1, 2, 3, 76.92. Okay. So 76.92. Yeah, so we can easily calculate. So once I have this, I can say, okay, Q is pi is V pi d squared over 4. The diameter of the pipe, so I'm going to use, will be 4Q over V pi, the square root, which is the square root of 4 times this. Remember, this is Q. This is volumetric flow rate. Okay? So you should know that. And this is remember, all that we have been calculating here is per hour. That is meter cube. You can convert to per seconds, because before we put it here, because this is going to be also in meters, and with SI unit, this is per hour. So you must make sure that you convert this to per seconds, just by dividing by 360. 60 by 60. That is 76. 76.92 divide 60 divide 60 again. That is 0.0214 or 213. 21366. 0.021366. So this is the same as 0.021366, but in meter cube per seconds. Okay, so 4 by 0.021366 divided by the velocity is given. It's 2.5 and pi here. All right. So we have 4 times 0.021366 divide 2.5 divide pi equals that, and then the square root of that will give you 0.1043 meters. Okay, so which is like 104.3 millimeter. Now, when you want to choose the size of the pipe, we have a 5-inch pipe. A 5-inch pipe is about 125 millimeter. That's the internal diameter. We have a 4-inch pipe. 4-inch pipe is about 100 millimeter internal diameter. So now, since I have this, for pipe sizing, once you get this, you don't go to the highest one. You don't go to the next well, you go to the next, I mean, the below the previous size of the pipe. For instance, size a 5-inch pipe is 125, okay, and the 4-inch is 100. So you go for 100. Don't go for 125. If you go for 125, since the diameter is going to increase, what happens? The diameter, if diameter increases, what happens to the velocity? The velocity will decrease, and then you will not be able to pump to push that slurry at the required or desired speed. So it's going to be sluggish. Okay. So in pipe sizing, once you get something like that, you don't go to the next size of the pipe, rather you go to the previous size before that. Okay. Did you get that? So that means we'll go for a 4-inch pipe. So 4-inch pipe, which is 4-inch pipe is 100 millimeter internal diameter. Okay, that's the size of the pipe that we'll go for. All right. Now the next is to calculate the power for the pumping. What time is it now? Wow, it's time to pass, eh? For you to get a power for pumping, I said, remember you are going to pump this and then through an elevation of 250. So there must be a frictional force and a frictional head, and there will also be a normal static head. Okay, so we are going to add the frictional head with that of static head to get the total head. And once we get the total head, then that's all. We can easily calculate. So what are we going to do? Let's get frictional head. We say frictional head is 4FLV squared over 2GD. That is HF. Okay? So which we just write 4 by F is 0.007 by total length. What's the length? We are given that the length of the pipe is 1 kilometer, so which is 1,000. And then velocity is given already as 2.5. Okay, but another thing again is when you get the size, you must walk back, because now if I choose, remember this is 104, right? I need to announce, okay, I'm choosing 100 millimeter diameter. I need to walk back to see the exact velocity that this will flow with. Okay, so we must do that before I can put the. I don't have to put 2.5 because 2.5 is not the exact. Once I put 100 millimeter size of pipe. So let's walk back to see what will be the velocity. Just from here, just from here that I put velocity. What is it? Q is VA, or velocity, or maybe which is pi d squared over 4, or velocity. Just from here, we make velocity the subject, okay, which is Q over A. All right. Now, and we just have with this and that, A is pi d squared, Q over pi d squared over 4. So the 4 can come up here. So I can just use this just to see how much, what will now be the velocity, since I'm now choosing 100 millimeter internal diameter. Okay? Did you get that? So what do we get as our Q? We got Q at 0.02. We have our Q at 0.021366. So I can just write this to be 0.021366 times 4 divided by pi. The diameter I'm using now is 100 millimeter diameter, so which is 0.1. So you just get that just to see what will be the exact velocity, pi d squared, 0.1 squared. So we'll have 0.1 squared times pi. I'll get something, I'll say, okay, 0.021366 divided by that, now times 4, you get about 2.7. So this is how much? 2.72. This will be the velocity that we are going to use to solve. Okay, remember as I said, if you check, if you use a 125 millimeter diameter, the velocity is going to be very, very small, that you will not be able to push that slurry. Okay, so we're using this. So I'm just saying, so for HF, I'm just going to use 1,000 times 2.72 divided by 2 by 9.81 times the pipe diameter that we have chosen to use. Okay, that's our 0.1. So that's 100 millimeter diameter. Okay, that's all. So we use this now to calculate the friction head. We have 4 times 0.007 times 2.72 divide 9.81 divide 0.1. So you get about 0.0388. I'm sure I missed something. Squared. Let's say times 2.72. Yeah, 0.105558. Okay, that is 0.10558. I'm sure there must be something that I missed somewhere. It's supposed to be about 105.6 meters. Okay, I have 4. This is 0.0007, 1,000, 2.7 squared over 2 times 9.81 times 0.1. Okay, so what is this 0.1? Yeah, 0.1 in meters. That will give you meters. Let's see 4 times 0.007 times 1,000 times 2.72 squared divide 2 divide 9.81 divide 0.1. Oh, okay, yeah, 105.6, sorry. So 105.6, I forgot to multiply by 1,000 here. So I have 105 point, all right, 0.58 or 0.6. All right, now this is the head. This is the friction head. And then we have our static head of 250 meters. So you can easily calculate the total head, all right? So total head, just clean off here. So total head is static head plus friction head. And our static head is 250 plus 105.58. So 105.58 plus 250 will give you 355.58. 355.58. So once you have your head, then you can easily calculate the power. All right, power is rho G H Q. That's all. So what is the density of the slurry? It's 1,400. 9.81, 355.58. Now you multiply by the volumetric flow rate of our slurry. This is Q for our slurry. That is 0.021366. Just like that. Okay, so 355.58 times 9.81 times 1,400 times 0.021366. That will give you 104.342 kilowatt. Okay. So that's with the power. But now remember, this is the power you will use to push it. But if you want to get the input power, then you must know the efficiency given to you. And remember, a pump, sometimes you might even be given, for you to have a pump, you can have a motor and a pump. There may be efficiency of the motor, there will be efficiency of the pump itself. And they want to know the power in. All right. Remember, this is not a transformer. I'm just saying I have a pump. You have a motor, which is an induction motor, driving a pump. The motor can have efficiency, and the pump will have its own efficiency. So if this is the total amount of power that is required, P out, here is P out. If you are given efficiency of motor and pump, you can easily calculate the power in into the motor by saying P in will be P out divided by efficiency of motor multiplied by efficiency of pump. Or sometimes you might be given overall efficiency. Okay? Did you get that? Wow, what time is it now? Well, it's your time to pass, right? So that's slurry equation. This is factories, November 2004, which they repeated in 2010, and we don't know whether they will repeat that again this time. But if they do that, what do? Throw your pen up, catch it, and start writing. All right? Okay, so thank you. We are going to close now. So our time to pass. Okay, thank you.